Hello and welcome to today's lesson when we get into the fun of writing and naming ionic formulas. So now we're going to put everything we've learned together and you will be able to write and name ionic compounds at the end of this lesson. So for starters, some objectives, things you're going to be able to do. You will be able to determine the oxidation numbers of elements, and we'll talk about what that means here in a second. And then you'll be able to write the formulas for ionic compounds. We'll do the naming in the next video. So for starters, we have these things called binary ionic compounds. Binary, this bi means two. So this is when two elements form an ionic bond. Example, NaCl, Ki. So this is sodium and chlorine. Sodium is going to donate its electron, form an ionic bond here. Potassium and iodine. So potassium is going to have a positive charge. Iodine is going to gain that electron, have a negative charge. They're going to come together as well. So those are binary ionic compounds. The first step to writing ionic formulas, so you should write this. There's I think 2 or 3 steps. Might be 3 steps. Step 1, you need to determine the oxidation number of each element in the compound. So if you write determine oxidation number, that will be oxidation numbers maybe. So you have to get all of them. That'll be sufficient. Okay, the oxidation number is the same thing as saying the charge. And your charge is going to be equal to the same as the number of electrons gained or lost. So we're trying to get either to 8 or 0. So we're going to look at these. Sodium has how many valence electrons? If you find sodium, it's in column 1, so it's got 1 valence electron. Easier to go to 0 than 8. So sodium is going to have a positive charge. You don't have to write 1, you just write a plus sign is fine. Aluminum has 3 valence electrons. So you're going to write positive 3 or 3 plus. Oxygen has 6, so instead of losing 6, easier to gain 2. Fluorine has 7. So again, you can just write a negative instead of a negative 1. If you want to write negative 1, that's fine too. I would pause the video and try these next 4 by yourself. I'm going to buzz through them quick. You can check yourself when you're done. So calcium is positive 2, potassium is positive 1, chlorine is negative 1, and phosphorus is negative 3 or 3 negative. Those are oxidation numbers. That's going to be really important. So really quick, pause the video, think to yourself, what is a binary compound? Question mark. What is an oxidation number? And then what is the oxidation number of nitrogen? All right, moving on. Step 2, writing ionic formulas. You're going to crisscross your oxidation numbers and drop the positive and negative charges. Okay, what does that mean? So if I have sodium and chlorine, I'm going to write my chemical symbols. I have Na and I have Cl. I write my oxidation numbers at the top. That was step 1. So sodium, as we said, was positive 1. Chlorine is negative 1. Step 2, crisscross oxidation numbers and drop the positive and negative charges. So I'm going to take this positive 1 and this negative 1. I'm going to cross them. So my 1 goes outside the chlorine. This negative 1 comes just past the sodium. And remove the signs. So now I have Na1 and Cl1. And if it's 1, you don't have to worry about writing it. But that's where we're at. So this would be NaCl. Your next one's calcium and fluorine. So calcium has a charge of positive 2. Fluorine has a charge of negative 1. We're going to cross and drop. So my calcium, and remove the sign. So calcium has a 1. Fluoride has a 2. And then you can rewrite it without the 1. It can be CaF2. I'll let you pause the video, try these next 2 on your own. I'm going to buzz through them quick. We'll see if we get the same answer. All right, that's what I came up with. Hopefully you match the same. That's step 2. That's really the last step. The only one we have after that is to simplify if we have multiples, and we'll talk about that in a second. So here's some practice. I want you to pause the video and try these, and then I will show you the answers here on the next slide. So pause the video and try these out. Hit play, you'll get your answers. So there are your answers for these. You'll notice magnesium and sulfur. This is the one that we have. Mg should be a positive 2. Sulfur should be a negative 2. When you cross and drop, you're going to get Mg2, S2. In this case, we can divide them both by 2. We can simplify. So we're just going to make it MgS. That's where we get that one from. Okay? All right. Well done so far. Moving on. There are some elements that have more than one oxidation number. If there's more than one possible charge, you will be told what the charge is, which is really nice. So if there's a number in parentheses, that's going to tell you the charge of the ion. For example, if I have copper 1, this is where we have to know Roman numerals. Copper 1 means it's copper with a positive 1 charge. Copper 2 is copper with a positive 2 charge. Iron 3 is iron with a positive 3 charge. Iron 2, iron positive 2 charge, so on and so forth. Anytime you see a parenthesis, the charge is going to be positive. Only your metals will have parentheses. Non-metals will never have a parenthesis. So it's only metals, always positive. I would like you to try these on your own. I'll do the first one with you. So I have iron. This is Roman numeral 2. So I know I have Fe positive 2. I have Cl minus 1. Do the same thing. Cross and drop. You're going to get Fe Cl2. Try those next two, and then we will move on. So pause the video, try those, and then we'll move on. Here's your answers. So again, copper 2 and oxygen, you have to reduce. Instead of Cu2O2, you have to reduce that. And then iron 3 and sulfur is Fe2S3. All right. Here we go. What do the Roman numerals after some elements indicate? And why do those elements have Roman numerals? So think back. What do they indicate? And why do some have Roman numerals, others do not? What's the distinguishing piece there? We have one little section left, and then we're going to wrap up for the day. So now, backtrack with me. We talked previously. Atoms that have unequal numbers of protons and electrons have a name. What do we call those? We're thinking we call those ions. More specifically, if they lose electrons, they become positive, we call them cations. If they gain electrons, they become negative, we call them anions. Now, what if I have a whole group of atoms that has a charge? So because charged atoms are called ions, what about if I have more than one? So if we have a group of atoms that have a charge, those are called polyatomic ions. Poly means many. Atomic refers to atoms. Ions have a charge. That's about as straightforward of translation as we can get. So poly is many. Atomic is atoms. Ions with the charge. So many atoms with the charge is called a polyatomic ion. I would like you to know these 6. So ammonium is NH4 with a positive 1 charge. So if you see the word ammonium, you know this is the formula. NH4 charge is positive 1. Nitrate is NO3 with a negative 1. Hydroxide is OH with a negative. Carbonate is CO3 negative 2. Sulfate is SO4 negative 2. And phosphate is PO4 negative 3. Those 6 I would like you to know. They will be on different quizzes and tests you have coming up. So make sure you're aware of those. Now let's practice using them. So ammonium. If you look at your list, ammonium is NH4. Has a +1 charge. Chlorine is Cl with a negative 1 charge. We are still going to cross and drop. This time you drop outside of, you put parentheses around it, you drop outside of your parenthesis. And because it's NH4, 1, Cl1, I can reduce that to just NH4Cl. You don't have to have parentheses, there's not a number. Magnesium and hydroxide. Magnesium is positive 2, hydroxide is negative 1. If I cross and drop, I'm going to have Mg with a 1 by it. Hydroxide is OH. Put that in parentheses and put your 2 on the outside. So then it can become MgOH2. I would like you to try these last 2 on your own. Pause the video, try those. I'll give you the answers on the next slide. So there is aluminum sulfate, Al2SO4 and ammonium carbonate, NH4 Here are your final questions. So what are atoms called when they lose electrons? What is a polyatomic ion? And then why do we swap charges and place them as subscripts in ionic compounds? So when I have Be plus 2 and I have Br minus 1, when I cross and drop, I didn't explain this, so I'm going to answer this one for you. This one has positive 2. This one has negative 1. The compound has to be neutral. Okay, so in order to balance my positive 2, if I have 1 beryllium, which is what I got when I crossed that, I'm going to need 2 of those negative bromines to make it neutral. That's why we cross and drop, is to make the simplest neutral compound we can. That's your answer on number 3. I apologize for not getting that to you sooner, but that is why we do it. All right, thank you for your time and attention. If you have questions, please come see me. We will do a bunch of practice, I promise. And I look forward to finishing out this unit with you. For now, enjoy the rest of your day, and I will see you later.